This question is on probability. Okay, so the question here is asking you for the probability that the first card bears a consonant. Okay, three cards are drawn from a box of 12, right? So yeah, you gotta, like, a consonant is just whatever is not a vowel that's a consonant. Okay, so just count the number of vowels and consonants here. The number of vowels is 5, number of consonants is 7. Okay, so yeah, if you like draw a probability tree, right? The probability of drawing a vowel is 5 out of 12. Probability of drawing a consonant is 7 out of 12. So the first answer, part 1, is just 7 out of 12. Okay. Part 2, the three cards that are drawn bear the letters B, E in any order. So for this one, right, the probability of drawing B, right, that is 1 out of 12. Because there's only one B among the 12 letters. Okay. Anything else, like others, this will be 11 out of 12. Then the probability of drawing E as your next card, right? There are two E's here. Okay, so the probability is 2 out of 11, because you see there's no replacement. That means after you draw the first card, there are 11 cards left. Okay, there are still two E's, so the probability of drawing E as your second card is 2 out of 11. And then the probability of drawing another E will now be 1 out of 10. Okay, so this will give you the probability of drawing B, E, E. Alright, but they say in any order, right? So you need to account for like E, B, E as well as E, E, B. Alright, you don't have to draw like the branch for all the others, right? Just like, okay, you can kind of imagine the probability of drawing E, this will be like 2 out of 12, and uh, then maybe B again, this will be 1 out of 11. You get the idea, right? If you can visualize, then you don't have to draw the branch. Okay, so the probability of this one is 1 out of 12 times 2 out of 11 times 1 out of 10. For EBE, it's 2 out of 12, right? Then there's one B, so 1 out of 11 times 1 out of 10. Okay, and then for this one, it's 2 out of 12 times 1 out of 11 times 1 out of 10. Okay, then you got to add this up, but let me draw something to your attention. If you multiply these fractions together, you see that you'll be 1 times 2 times 1 on top, and at the bottom is 12 times 11 times 10. For the second one, it seems like a rearrange. I mean, it seems like you're multiplying different fractions, right? But then observe the numerator and the denominator, right? You're multiplying the same numbers, just rearranging them. So actually, they all give the same value. So just look out for this kind of situations. You don't have to go and multiply every single fraction, right? You find one, and then you just times 3, because the values are all the same. Okay, so the answer will be 3 times, like, let's just take the first fraction, 1 times 1 times 1 times 2 times 1 over 12 times 11 times 10, and this should give you 1 over 220. Okay, for part 3, they're asking for what's the probability that all three cards bear vowels, right? So to visualize this, it'll help if you write down all the vowels first, right? There's one I, two E's, sorry, there are two I's, two E's, and one A, right? 5 vowels. Okay, so what combinations can you form, right? You can form a combination with I, and then yeah, you can rearrange this in any order, like I, and then EII, right? But okay, let's not bother with the different combinations first. Okay, just see how many unique vowels we can form, right? Unique vowel combinations. Okay, so first one is IIE, second one EEI, third one, okay, yeah, sorry, two of the vowels have to be identical. Okay, IIE, right? Uh, IIA and EEI and EEA. Okay, this should be it, because only I and E have double, right? So you can only form combine, like, only you can only use I and E to form like three vowels where two of them are identical. Okay, so after you sum up all this probability, right, then you can account for all the rearrangements by just multiplying by 3, right? Because remember, in part 2 I was saying, no matter how you rearrange, the numerators and the denominator will be the same, right? Because you're multiplying the same numbers. Okay, so let's find the probability of IIE, right? The probability of drawing an I will be 2 out of 12 times 1 of 11 times 1 of 10. Then for IIA will be, okay, 2 of 12, 1 of 11. Oh, wait, sorry. Probability of drawing E will be 2 out of 10, because there are two E's, right? Okay, then IIA will be 2 out of 12 times 1 over 11 times 1 over 10. EEI will be 2 over 12 times 1 over 11 times 2 out of 10. And then EEA will be 2 out of 12 times 1 over 11 times 1 out of 10. So you see combination 1 and 3 they're actually identical, then 2 and 4 are identical, right? So you can kind of shorten your working a little bit. Okay, so to calculate the answer, right, we will take 2 times 2 over 12 times 1 over 11 times 2 over 10, right? So this accounts for 1 and 3, right? That's why it times 2. Then after that, you add 2 times the other two combinations, 2 over 12 times 1 over 11 times 1 over 10. Okay? And then to account for all the rearrangements, right, where you mix up the elements within a combination, you just times 3 to everything. Okay? And the answer should be 3 out of 110.